Today's lesson is on graphing quadratics in the form y equals ax squared plus bx plus c. But before we start that, I just want a quick review of the properties of what happens in the other forms of graphing quadratics. So first, y equals ax squared. So that means we only have the very first term of the standard form. So here's one specific example, y equals 2x squared. It has the axis of symmetry x equals 0, which is just the vertical line at x equals 0, which is the exact same thing as the y-axis. So the parabola wraps perfectly around the y-axis. And as you can see, the vertex is right at 0, 0. So if you have a monomial quadratic, this is always true. The vertex is always at 0, 0, and the axis of symmetry is always that y-intercept that cuts the parabola in half. Now, the other form, y equals ax squared plus c, we've added that n term, but we still don't have that middle term. So, because we don't have that middle term, once again, the axis of symmetry is x equals 0, same as above. That means the parabola wraps perfectly around the y-axis. But in this case, the vertex is the point 0, c. What I mean by that is whatever this value is will tell you where the vertex is here. So in this case, x squared minus 4, the vertex will be at 0, negative 4, which if you look here, it is. Vertex at 0, negative 4. So, monomial, vertex 0, 0. If it's a binomial missing that middle term, it's always going to be 0 and then whatever the value at the end is. And they both wrap perfectly around the y-axis. So now here we have a full standard form quadratic, 3 terms, and we finally have something that has that middle term, negative 6x. That middle term makes everything a lot more complicated. Our parabola will no longer wrap around the y-axis. It'll be off-centered either to the right or to the left. So right here is a formula, x equals the opposite of b divided by 2a. Plugging in the numbers from your equation into that formula tells you where the new axis of symmetry is. It is no longer x equals 0. So let's plug in our numbers from the equation. So here we have x equals the opposite of b, or negative b, divided by 2a. So in this case, remember, you've got a, b, and c of your equation. So the opposite of b, if you look here, b given to you is negative 6, and the opposite of that is going to be a positive 6. And then divided by 2 times a, and in this case, there's no number in front of x squared, so it's simply just 1. 2 times 1. And 2 times 1 is 2, and 6 divided by 2 is 3. So my axis of symmetry is x equals 3. And I now want to graph the vertical line of x equals 3. So I find 3 on the x-axis, and I draw a vertical line through 3 on the x-axis. That line right there is my axis of symmetry and is the line that will cut my parabola in half. The next step is to find the vertex, the middle point of my parabola. And in this case, if you look up here, a is a positive number, so I know that my parabola is going to open up, which I know I'm going to have a minimum point. So if you think about this little parabola up here, the sketch, it has an axis of symmetry that cuts the parabola in half, and then it has a vertex that is the middle point. So as you can see, the vertex is going to be on that axis of symmetry. So I have to use my axis of symmetry to find my vertex. So in this case, x equals 3, and my vertex is always a point that has an x value and a y value. Well, because we know our vertex is on our axis of symmetry, whatever you get for your axis of symmetry is the x value of your vertex. We just now have to find y. Well, all you have to do is plug x in back into your original equation. So my original equation, x squared minus 6x plus 9, I'm just going to plug in 3 for x, so 3 squared minus 6 times 3 plus 9. And 3 squared is 9, and 6 times 3 is 18. So 9 minus 18 is negative 9, and negative 9 plus 9 is 0. So that's the y value of my vertex, so I can plot my vertex at 3, 0. The last steps is to find the other points of your parabola. So you're going to make an xy table and pick points, plot them, and reflect them. But the key thing is you always want to pick points to the right of your axis of symmetry. You don't just want to pick any points, you want them close to that middle area, the axis of symmetry. So I'm going to pick 3, 4, 5, and 6. Well, we already figured out that when you plug in 3 you get 0, and then when you plug in 4 you get 1. When you plug in 5 you get 4, and when you plug in 6 you get 9. So if you plot the points, 3, 0 over 4 up 1, and then you can reflect that one to the other side, over 5 up 4, and you can reflect that one to the other side, and last one over 6 up 9, and then you can reflect that one to the other side. So you can connect, and here you have a sketch of the parabola for the quadratic equation given. So just simply remember, you need to find your axis of symmetry. You use your axis of symmetry to find your vertex. When you make your xy table, always choose numbers to the right of your axis of symmetry, and then you can reflect your other points. And that is it. Good luck.